Okay, I'm gonna actually stop you guys where you're at because I was walking around and I'm seeing that I think some people are not clear with the directions here. But what this comes down to is basically a two-part question. So part one is to graph it. So as I was walking around, there's people that are not graphing right. So we got to make sure that's correct because part two is based off of your graph for part one. So just a little quick review on how to graph. Just a regular standard line. When you guys graph lines, you always start with the y-intercept. Well, first of all, let me back up even further. When we graph lines, we like to see them in this order. In that form right there, it's called Slope-Intercept Form. The reason why we like to see it like that is because we can pick out two important pieces of information from it. So this is called Slope-Intercept Form because this is the slope and this is the y-intercept. So in this graph, this right here is our y-intercept, and that's what we put on the graph paper first. So as I was walking around, I was seeing people put stuff on the x-axis first, and then some people were putting points on the graph, like not on any axis. I think what those people were doing were trying to plot the points for number 2, but you can't do the second one until you have the line for the first one. So the very first dot is up 5. So we start off here. The second thing we do is we use the slope. The slope is located right here in the front of the x, and I like to make it a fraction. The signs of each number determine the direction that you have to move. So if the top number is a negative, that means to move down. If the bottom number is a positive, that means to move to the right. So from this dot, we have to go down 2 and then right 1. Down 2, right 1. Hey guys, over there there's an iPad right there. If you guys just unlock the iPad, you can see the new seating chart, so you can find your seats. So then we can just continue the pattern until we run off the edge of the graph. Go like this, down here, right there, and then I'll go in the other direction also. So it ends up being like this. And we draw the line all the way through it. So that's the first part. The second part, part 2, says, which of the following ordered pairs land on the line? Select all that apply. So we want to know which ones are going to hit the line. So we start off with 1, 2. 1, 2 is 1 to the right and 2 up. So that's right here, so it doesn't hit the line. Let's see, we got 3, 1. 3, 1 is right here. That doesn't hit the line either. Negative 1, 7. Negative 1, 1, 2, 3, 4, 5, 6, 7. That one does. So that we got to check that one off. I got negative 1, 3. Negative 1, 3. That one doesn't. I got 2, 1. 2, 1. That one does. So we check that one off. Then we have 3, negative 1. 1, 2, 3. Negative 1. That one lands on the dot also. So we check that one off. Negative 4, 5. Negative 4. 1, 2, 3, 4, 5. That's here, so that's not on it. 5, 0. That's 5 to the right. 1, 2, 3, 4, 5. So that's right here. That's not on it either. And then we have 1, 2, which I think we already had because that was the same as the other one. So if it wasn't there the first time, it's not going to be there the second time either. So here's what I had you do. If you read the paragraph down here at the bottom, it says if the point lands on the line, then it's called the solution. So basically, these 3 that we checked off, they're considered solutions to this equation because they landed on top of the points once we graphed them. There is another way to do it. There's another way to check if it's a solution. And you can just plug those numbers in. Plug it in and see if it creates a true state. So don't forget, every point that we have is created by an x value and a y value. And every equation has an x and a y in it. So if we want to check to see if it's a solution, what we can do is we can just plug in those numbers instead of graphing them. So that's another option. So that's what we're going to do next. This entire chapter is about systems of equations. We're going to learn how to solve them like 3 different ways. So what is a system? It's basically a collection of 2 or more equations. Usually their variables should match. So we're going to start off with just 2 problems. 2 problems at once. That's called the system of equations. And this is the part that you really have to understand today. When I ask you to solve a system or find the solution to a system, this is how you find it. Or this is the definition of what a solution is. A solution to the system is the ordered pair or ordered pairs, because there could be more than one, that would create a true statement in all equations in the system. So it has to be able to work in all of the equations. So I don't care if you have 2 or 3, if you tell me that a point is a solution, if you go back and plug it in, it needs to make a true statement in all of your equations. So I'm going to show you that real quick in this one. It says, example 1, or just the example, check if 2, 5 is a solution to the system. Here's our system. This is equation number 1 and equation number 2. So to check if it's a solution, all you have to do is plug it in and see if it's going to create a true statement. Basically, we're going to check to make sure it's equal. So this is your x, this is your y. So we put a 5 right here, equals 2 times 2 plus 1. So where the heck did this 5 and this 2 come from? It came from the point. So I just plug them in. And this is the question. Are they really going to equal each other? So in this right side, if you type it all into your calculator, you get 4 plus 1, that's 5. So it works. Now at this point, you can't say that it's a solution yet though. Because in order to be a solution to the system, it has to work in both. So now we got to check it in the other one. Same exact numbers. So I'm going to put the 5 here. There's a negative right before the x. I put negative, and I put the 2 in there, plus 7. So we simplify, because again, the question is, are they really going to be equal? So we end up with negative 2 plus 7 is 5 again. So since it works in both, the answer is, yes, it is a solution to the system. So that's how you could test points. If you don't want to graph them and you want to see if it's a solution, all you got to do is plug it in. And that's what's going to happen on your first 3 questions of your assignment today. First 3 is going to say, is it a solution? All you got to do is plug it in and see if they match. If the first one didn't work, like if we would have got 2 different numbers right here, you don't even have to check the second one. Because if it didn't work in the first, it's already not a solution to your system. So you got to make sure it works in both. Now, the part that we're going to emphasize in this lesson is more about the graphing stuff. So I'm going to go into what it means to be a solution and how to find it by looking at the graphs. So in this example right here, this one is like almost, I want to say like the easiest version of the question. And the reason why is because someone already did the graphs for us. Now when you guys take your test, or when you see the homework assignment, you won't always have to graph both. Sometimes you will, but sometimes they'll graph one of them for you. I can think of one specifically that's like, I think it's on the test. There's a circle. You guys, you haven't, I don't think, graph circles in algebra. I think you did in geometry, but we don't expect you to remember that. So when it comes to the test, the circle is going to be there for you already. You'll just have to graph the second one. Now, it's not limited to lines, though. In addition to lines, you guys have to remember how to graph all 7 functions. Or wait, how many are there back there? 1, 2, 3, 4, 5. You have to remember all 5 functions that we had graphed in the previous chapters. Like in chapter 1, I think we covered all 5 of those. So you have to know all of those still. Which isn't hard because we do it in the calculator anyways. We just got to find where they cross. And that's the whole idea here to these graphs. If you want to find where their solution is located, all you got to find is their point of intersection. Point of intersection. That's a fancy way of just saying where they cross. So if they ever ask us to solve the solution by graphing, we graph both shapes, and then we just label where they cross, and then those are your solutions. So I don't know if you guys realize this, but that equation and this equation, they're the ones from above. Look at the number where their solution is. It was the number that we tested. So all that means is the point is on the first line, The same point is on the second line, so that's basically telling us that the two lines are crossing right there. That's the only way it could be a solution, is if it works in both, or if that's where they cross. Now you can see, well, I can see, what do you guys think happens if you mess up one of your lines? What if you don't graph one of your lines right? What's that going to do to your point of intersection? It's going to move it, right? So that's why we got to make sure that our graphs are pretty accurate. If you mess up the slope, because remember in the warm-up or the bell work, I saw instead of graphing 2 over 1, some people were doing 1 over 2. That's going to cause your line to not be as slanted, and then that would change the point of intersection. So you got to be really careful when you guys are graphing this stuff, because it will have an impact on where they cross each other. So what we're going to get into right now is actually graphing. And I threw in all kinds of different types of examples. So this is on the next page. I threw in all kinds of different examples, trying to encompass, some of those things that you guys are supposed to know back from chapter 1. So I think this will be a good review for us. I guess we'll just start off with number 1. In number 1, I'm looking at it. I don't see any exponents. I don't see any fancy symbols like square roots, absolute values. I don't see anything. So right away that tells me they're lines. But in order to graph a line, they have to look a certain way. You have to get the y's by themselves first. So in the first one, I need to subtract x. So this equation turns into y equals negative 1x plus 3. So what I'm going to do is I'm going to just go ahead and graph that one first. 1, 2, 3. We always start with the y-intercept, which is the number at the end. I'm going to turn this into a fraction. So the slope is negative 1 over 1. So that basically means down 1, right 1. Down 1, right 1. So it just has this pattern where it goes diagonal. And I actually, I like putting as many dots as possible, because one of those dots is going to be the answer. A lot of the problems that we give you, they work out nicely to where you don't have fractions. If there was fractions, we would probably just solve it in the calculator, because the calculator could do this stuff too. So there's the first one. Same thing with the second one. We have to get the y by itself first. So we're going to have to subtract x. I'm going to kind of work sideways since I'm running out of room here. I got negative 2y equals negative 1x. And then I just divide by negative 2. So in the end, this one becomes y equals positive 1/2 x. Now, usually when we graph in the y equals mx plus b form, there's usually 2 numbers there. There's one next to the x, and then there's one at the end. What is the number at the end when you can't see it? Yeah, it's a 0. Before the break, I was working with my freshmen on graphing lines, and a lot of them kept saying it was a 1. But if it was a 1, you would have seen it. We don't put invisible ones at the end. It's got to be a 0. So the graph to this one, actually I'll leave this in red, starts here. It's got a rise of positive 1 and positive 2, so that means up and right. So we go up and right 2, and there it is. It landed on top of that dot right there. Now, just graphing it isn't enough, though, you guys. You have to tell me where they cross. And even this is not good enough. If you circle the answer, that's not what we're looking for on the test. On the test, you have to give me the coordinates of where they're crossing each other. So we would go like this. What is that? Positive 2, comma 1. That's our solution to that system right there. Let's see. I hope you guys have calculators, because I'm going to need your help here in a little bit. Let's see. I want to do. Let's skip over to problem 3. Problem 3 right away. Based on our prior knowledge, I see that little 2 right there, and I know that it means one of these. So it's going to be a parabola. So what I'd like for you guys to do is, in your calculators, graph a parabola for me. Graph that one, x squared minus 5. So type it into your calculator, go get into the graphing mode. If you don't have a calculator, go get one. So just make sure, you sit right there. Just make sure you guys, when you type this stuff in, you got to be into the, oh, I don't want to do that. You got to be inside the graphing option. Let me change the settings on this calculator. Can't see anything. Okay. So to graph, delete this. We go into the first equation and we type x, that's the one under the red button, squared, right next to the red button, and then minus 5. And we hit F6 for draw. And if your graph doesn't look like mine, you might have to hit Shift F3 and change it to the standard viewing window, the 10 by 10. So it looks like our graph is starting down here at 0, -5. And we should have already known that because of the h and the k stuff from the poster in the back. H is the number that's inside with this x, and then this is actually the k right here. So that's how you get your vertex. That's just a little bit of review. And then if I wanted to find other dots, I can go into the calculator and just hit trace, and I can manually type in numbers. Knowing that 0 is the center, I just go to the right one. So if I type in 1, it takes me to -4. So I go right here. And because I know that parabolas have a line of symmetry, I know that there's going to be another dot right here. And then I type in 2. When you type in 2, it goes over to -1. So 2, -1, which means that -2, well, -2 is going to be at -1 also. And I type in 3, and I just keep doing this until it goes off the charts, so I can't see it anymore. So at 3, it's at 4. 3, 1, 2, 3, 4, it's right here. And then -3, 1, 2, 3, 4, it's right here. I'll type one more and see if I can get it to sit. Type in 4. 4 is at 11, so that's off the charts already. So our parabola looks like this. So now what we need to do is we need to try to graph the line. I can tell the second one's a line because it doesn't have exponents, it doesn't have radicals, it doesn't have anything. It's just x to the first power. So in this one, it starts up at 1, and my slope is -1/1. So -1/1 needs to go down 1 and right 1. And then down 1 and right 1 again, and you can see it hit. That's what we're looking for. Now it also, I don't know if you guys can see this, but that line doesn't just go that direction, it goes up also. So if I continue that pattern, up 1, left 1, up 1, left 1, up 1, left 1, bam! It actually hits twice. So this one, it has 2 solutions. So remember, a solution is wherever they cross each other. That's all it is. So we give everyone the location of those points of intersections. There's one there and there's one there. So our 2 answers for this are going to be at 2, -1. And then the other one is going to be at, is that -3? 3. +4. These are our solutions. So you can see that usually when you have lines, they're only going to cross once, if they cross at all. You could have parallel lines, and that means you don't have solutions because they don't cross. But as soon as you start dealing with curves, it makes it possible to cross multiple times. So these things could have more than one solution just depending on how curvy it gets. For example, if it was an x to the third shape goes like this. If I draw a line, it could hit, looks like 3 times. So it just depends on the shape. Okay, let's see what else we got. Oh, I got another one. Let's try number 4 real quick, and then I'll give you some time to practice in your packets. On number 4, looks like a square root. You guys remember back to chapter 1, square root shapes have a starting point, and they go off like this. Now, to find that starting point, you don't need the calculator for that. The starting point is going to be the opposite of that number, and then the same as that number. So it's -4, and then 2. That's where this graph is going to start from. And that's how you get the H and K stuff from the poster at the back. It's always the opposite of what's grouped with the X, and then a number at the end. So my first dot is 1, 2, 3, 4 to the left, and then 2 up. Now for the rest of the graph, though, I will use the calculator for that. So that way I can just type stuff in. So I'm going to change this from x squared from the last equation. I'm going to turn it into square root. Square root is shift x squared. X, what was it? Plus, the problem said -1? Well, no, when you type it in the calculator, it needs to be the original problem. So it's going to be x plus 4. And then at the end, it's going to say plus 2. So from there, let's say we go into draw. And now I can go into trace. And I can go find all my numbers. Now, just depending on your teacher, some teachers make you graph the decimals. I don't. I just put the whole numbers and the integers and stuff. So I know this graph is going to start at -4. So if I trace to -4, it's going to be at 2. I already know that. I found that without using the calculator. I don't want to go left, though, because the graph doesn't go left. It goes to the right. So don't type in -5 because there's nothing there. As a matter of fact, I'll show you. If you type in -5, it says error because the graph does not exist over there. It's undefined, basically. So instead of going to the left, go to the right. If you're at -4, go to -3 next. You type in -3 and it gives you +3. So -3, +3. And we type in -2. -2 is a decimal. Type in -1. It's another decimal. So I type in 0. Oh, there it is, 0.4. And guys, if you want to estimate the decimals, you can. It's just that with estimating, it's not very accurate. So it could cause your graph to get kind of wavy and weird if you're not careful. That's why I stick to the integers. I type in 1. It's a decimal. Type in 2. Another decimal. Type in 3. Another decimal. 4. Oh my gosh, 5. Oh, there it is. I typed in 5 and it gave me 5. 1, 2, 3, 4, 5. And I have this feeling that it's probably the last one that's going to fit. That's not a decimal. 7, 8, 9. Yeah, so I'm only going to go up to those points there. So that's the first shape. First shape goes off like this. And the second shape's a line. Now you guys should note, it only has one letter. These ones are easy to draw because it's only going to cross through the x-axis at 5. So if I go 1, 2, 3, 4, 5, here's the 5th dot. Since I had to go to the right to put that dot, I go straight up and down. Does this one have a solution? How many? Just one. This is the solution right here because a solution is just where they cross. So then we just tell everyone where that's at. 5 to the right and 5 up. There's our solution. And that's all there is to this stuff. Graph them both, find where they cross, and then tell me the locations where they cross. So in your packet, let me take a look at the packet. So if you guys look at the packet, 1, 2, and 3 are like things we did for the bell work, where you have to plug it in to see if it's equal. On 4, 5, 6, and 7, they already drew the pictures for you. So you just got to tell me where they cross. And then on 8, basically to the rest, 8 through 15 is draw your own graphs. And I'm going to have you guys do the entire assignment except for number 11, because number 11 is circled, and I don't want to go into solving or graphing circles with you, since the one on the test is already graphed. So for 4.1, it's all, let's skip number 11. Yeah, everything else should be doable. So you got roughly 25 minutes. Oh, and I made some changes for big math ideas. I'm going to make that assignment due 2 days after it's assigned. So instead of making it due the day of the test, I want you guys to try to start keeping up now. So I'm going to make it due I'm going to give you 2 days to do it. So today is 4.1. It's going to be due by Wednesday at midnight. So try to keep up with that stuff too, so it's not going to be overwhelming the day before the test. So that one on the board right there, it says graphs. If you're in the graphing menu, those are the 3 buttons you have to hit to get the absolute value bars for your equation. But if you're just calculating stuff in the regular calculator mode, you just hit F4 and then F3, and that'll get you the absolute value bars if you need to type stuff in that way.